welcome to the Boolean Brain. In continuation to the LeetCode Daily Challenge series, we are here on day 6 where we are going to solve today's problem statement from LeetCode. The title says maximum level sum of a binary tree. Given the root of a binary tree, the level of its root is 1, the level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of nodes at level x is maximal. Let us try to understand this with the help of example. So this is a binary tree. So this is level 1. These 7 and 0 are at level 2. 7 and minus 8 are at level 3. So we have to return the level which has the maximum sum. Here the sum of level 2 is 7 plus 0 is 7, which is the highest as compared to 1 and minus 1. So we return 2. Okay, now the immediate solution that you should come to your mind is by looking at the keywords. So the keywords are binary tree and we have to go level by level. So whenever these keywords are mentioned in the problem statement, the first thing that should pop to your mind is BFS and using Q. So Q is the data structure which has the principle of first in, first out. So we start iterating with level 1. We process the children of level 1, then again add the children of level 3 while processing 2, and then go to level 3 and subsequently go to the next levels. So the key data structure here is level BFS, that is Q. So now the prerequisite for solving such problems is level order traversal or BFS on a binary tree. I hope that you are comfortable and aware of that. Even if you are not comfortable, you will be able to understand this with the help of current code. Now, we want to start from level 1. Now, I need to declare a data structure first. So, the data structure that we are going to use is Q. I declare data structure of type tree node. Now, we have to start from level 1, right? So, let me declare a level variable starting from 1. Now, initially I need to push the root. So I push the root. Now I need to traverse level by level. So I write a loop till Q is empty. So till Q is empty. So this is basically the level order loop. Okay. Now when we are at level 1, what is the element size of elements at current level? It is Q dot size. Now I want to, when I'm at level 1, I want to process and keep a sum of these elements. So I first declare a local variable sum where I'm planning to keep sum of all the elements in the current level. So I start another loop where I is starting from 0 and I is less than size of the current level, I plus plus. Here we try to fetch the nodes from the queue. First, node is queue dot front, and we also pop it from the queue. Now we need to keep a track of sum in the local sum variable node arrow var. Okay. Also, now for in order to process the children of 1, we check if node arrow left exists, then we push that node into the queue. Similarly, we check if the right element exists, we push that as well into the queue. Okay. Now, this way, at the end of this loop, we are having the sum of all the elements at that level. So here we can add a condition if now in order to add a condition, I need another global maximum. Let me assign the lowest value possible. So this is int min. Now I will check if the current sum is greater than maximum. I will update the maximum. Okay. Now I also need to keep a track of the level. So I'll declare that into answer. So initially my answer is, let's say, -1. And whenever I'm updating the maximum variable, I will update the answer as well. So answer is nothing but level. So where we are keeping a track of level, I need one more variable to keep a track of level. Initially assigned to 1 because we are starting from root. So root is at level 1. And this is for outer loop is for the level order. So after completion of this loop, we can basically update the level. And at the end of this loop, we can return the answer. Okay, let us try to run this. Oh, sorry. I think it's double. My bad. Yeah. So sample test cases are passing. Let us try submit this. And yes, so the solution is successfully accepted. Now let us try to understand the time and space complexity of this approach. So if we carefully observe, this outer loop is running level by level, and this inner loop is running for all the elements in that level. So in short, our logic is iterating on all the elements of the tree. So it's O of n. And in between, the logical processing in between is nothing but Q push and Q pop. So this happens in O of 1, so we don't need to take care of that. Next is the space complexity. Are we using any extra space? Yes, we are using queue. We are adding elements to the queue, but we are only adding elements which in the queue which are at maximum one level. So in worst case complexity, we can consider that all the elements are present, although it is not possible, only n by 2 can be present at any point. So, but for the big O complexity, we make it O of n. So the time and space complexity is for O of n. I hope the approach, problem statement, and the code is clear to you. If you have any queries, please do let me know in the comments. Thank you.